All right, Algebra 2, Lesson 49. It says using the binomial theorem. A lot of this, I think, overcomplicates how to do this. So I'm going to show you everything, but I'm only really going to teach you one method because at this point, understanding one method is going to be more beneficial than looking at a lot of it all at once. Does that make sense? If I can understand how to do this one way, sometimes learning one way to do it is a little bit more grounding than, hey, here's 3 different ways to solve this really complicated equation, right? So what we're talking about is taking a set of terms, you know, like an a plus a b, right, where we've got some variables there, and putting them to an exponent and expanding them, right? So seeing what that is in expanded form. So, you know, we can take a plus b to the 0 power. Anything to the 0 power is 1. If we squared it, what we're going to wind up with is foiling. So, you know, we get a plus b times a plus b is where that's squared. If it was just to the first, I wind up with exactly what I started with. So a plus b to the first is really just a plus b. And really, if you look down here, if you simplified it, you would see that that's true because really, I'm getting b to the 0, which is just 1, right? I really don't need that there. The second set, I get a to the 0. I really don't need the 1, so I'm winding up with a plus b, right? Because anything to the first is itself, correct? Okay. Now, if I square it, that means I'm going to FOIL, so I get a squared plus 2ab plus b squared, right? And we could see that if we FOILed it. Really, it's foiling, but we're seeing all of the exponents for everything, including the zeros. Okay, so even the things that aren't actually there, we see all of that, and I think that's what makes this look more complicated than it really is. Does that make sense? Okay, so you can even, you know, do 2 to the 3rd, and what this is showing me is what my coefficients are going to be. I'm going to have 1, 3, 3, 1. It's going to start off as a cubed, then go down to a squared, then a to the first, then a to the 0. It's going to start off b to the 0, b to the first, b squared, b cubed. Now let's just talk about this for a second. Let's just talk about the pattern of the exponents of the variables, okay? Let's come down here to a plus b to the 3rd. All right, it's a plus b to the 3rd, okay? What do you notice about just the very first set in that? It's got a coefficient of 1, okay? And notice that all of these start with a coefficient of 1, right? They always start with a coefficient of 1, okay? What do they, the last set, what coefficient does the last set always have? 1, right? We see a 1 here, we see a 1 here, we see a 1 here, okay? This is creating what we call a palindrome. Do you guys know what a palindrome is? It does repeat, but basically it looks like a hyperbola or like a parabola, okay, something like that. It starts, but it ends exactly the same way it started. It goes up, but it's symmetrical, right? The St. Louis Arch is an example of a palindrome in appearance-wise, in literal physical world. But what you're seeing with these is that the coefficients form palindromes, right? It goes, even as we come down here, we saw 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? So it went 1, 3, 3, 1, right? It ends up going back down exactly the same way it went up, okay? But look at the exponents here. Notice, what does a start with here? 3, okay? Whenever we squared it here, what did a start with? 2. When this was to the first, what did a start with? 1. All right, when it was 0, what did a start with? All right, so it's sufficient to say that the first variable is going to start with the exponent of the exponent, right? But the second variable, how does it always start? 0, 0, 0, 0. So it always starts with the lowest possible exponent. The lowest possible exponent is always 0, okay? So the first variable starts with the highest exponent it can start with, which is whatever we're exponing it by, right? whatever power we're taking it to. And then let's look at the pattern again. Now, I'll explain 3 and 3. We get those numbers here in a little bit. But look at the exponent of a here. What happened? It descended by 1. And what about the b? Went up by 1. All right, now look here. What continued to happen? A went down again, 1, and B went up 1. And then here A went down and B went up until they've completely switched places, right? The first variable will always start at the highest, and each term will descend until it gets to 0. The second variable will always start at 0 and ascend until it gets to the exponent that we're working with. Does that make sense? So we should always know what the variables or what the exponents to my variables are going to be. Does that make sense? The only thing that we have to worry about then is, how do I know what the coefficients are going to be? How do I know? I know that the first one is going to be 1. I know that the last one is going to be 1 because that's the pattern, right? So how do I know what happens in between? Well, that's Pascal's triangle, okay? If we come down here, now this only shows you to the 4th, but it always starts, okay, at the top is 1. The outside terms are always 1, 1, 1, 1, 1, 1, 1. But notice, okay, so at 0 we're at 1. At 1 we're 1, 1. At 2 we're 1, 2, 1, right? Okay, 3, 1, 3, 3, 1. 4, 1, 4, 6, 4, 1. Now, how do we get, this is what I want you to understand, is that really what you don't see is out here, there are zeros. Okay? There's nothing there, right? I want you to think about this in terms of addition. What's 0 plus 1? 1. So that is a 1. What's 1 plus 0? So we get a 1 here. Okay? Now, there's also a 0 here and a 0 here. So what's 0 plus 1? So I get this one. All right? So I'm going to come over. What's 1 plus 1? 2. So I get this 2. Okay? What's 1 plus 0? So I get that 1. Okay? All right? Put a 0 out here. 0 over here. Okay? What's 0 plus 1? So I get this 1. Okay? What's 1 plus 2? So I get this 3. What's 2 plus 1? So I get this 3. What's 1 plus 0? So I get that 1. Okay? We got a 0 out here. What's 0 plus 1? 1. Okay? What's 1 plus 3? All right, so I get a 4. What's 3 plus 3? So I get a 6. What's 3 plus 1? So I get a 4. What's 1 plus 0? So I get a 1. Could we keep going? Yeah, in fact, okay. So I'm going to drag this down, and you're going to tell me what the coefficients are going to be. Okay? Let's say we have a plus b to the 5th. What's my first term going to be? 1. What's the second term going to be? 5. What's the next term? 10. The next one? 10. And then 5, 1. Okay? Now you'll notice that it will always come down the same way it went up. Okay? Now, there might be 2 of the same term in the middle. There may be only 1 term in the middle, depending upon how many terms there are. The other thing I want you to notice is how many terms there are. Okay? Notice how this is to the 5th. How many terms are there? Right? There was 1, 2, 3, 4, 5, 6. There will always be 1 more term than there is exponent. Always. Okay? Notice up here, we had to the 0, but there was 1 term, right? 1 exponent, 2 terms. 2 exponents, 3 terms. All right? So do we see the pattern? All right, so if I come back up here, notice that this last one in here, this a, b to the 3rd, right? Do we understand now how we got coefficients 1, 3, 3, and 1? Because if we come down here to the 3rd, right, we see 1, 3, 3, 1. So these numbers in Pascal's triangle represent the coefficients of the terms. Does that make sense? Okay. All right, and so if I know what I'm taking as set 2, then I can draw Pascal's triangle, see what all my coefficients are going to be. I know that my first variable is going to have the maximum exponent, the second variable is going to have the minimum, and then each term is going to have the next coefficient, right? And then that first variable is going to drop one exponent. The second variable is going to go up one exponent until I complete the whole thing. Does that make sense? Yes? Okay. All right, so they show you other ways to do this. I just don't think it actually assists you. This is what we call the binomial theorem. If it helps, it's here. You can look at it. You have the notes, right? If this makes sense to you, great. Okay, and then they have this, right? Doesn't that look great? That took me like an hour to make that. I don't think that this, in reality, is going to help you understand this any better. Does that make sense? Do we understand how to draw Pascal's triangle? Do we understand the pattern of how these things are going to go in? Okay, then that's what we need. Okay, we don't need really a lot else. Okay, now we can talk about application. The binomial theorem can also be used to find probabilities for a binomial experiment. A binomial experiment has exactly 2 possible outcomes for each trial, where one outcome is a success and the other outcome is a failure. Okay, the probability of success is the same for each trial because there are only 2 outcomes. So P plus Q equals 1 because each of them has a probability. P, probability of success, is 1/2, like flipping a coin. And probability of failure is also 1/2, right? 1 and 2. So 1/2 plus 1/2 is 1. If you wanted to solve for just 1, let's say you wanted to solve for a failure, you take 1 minus 1/2. You'd still get 1/2. So there are some examples of binomial experiments. For one, if our experiment was to flip a coin 100 times, right? And we said it's a success if it's heads, it's a failure if it's tails, right? So, P would still have a probability of 1/2, right? Because we have one thing that's a success and we have 2 total possibilities, right? We understand probability. It is number of desired over total, right? Failure is the same thing, right? We have 1 possibility for failure, number, okay, over 2 possibilities. Now, if we change that to rolling a number cube, right? A number cube has how many sides? 6 sides. But we say a success is rolling a 2. All right, well, what's the probability of rolling a 2? 1 in 6. What's the probability of rolling anything other than a 2? 5 and 6. So that's how we see 1/6 and 5/6 here. Okay? So those are different experiments that can be done. So here you have binomial probability, and we can use this, and you will need to be able to use this. Okay, now this is not based upon the same thing that we did really early on. You can still do this. Okay, so this is based upon C combinations, which we can run in our calculator, where you want to know what these different variables mean. M is the number of trials, so the number of times I'm flipping the coin. N is successes, right? So then we take times probability of number of successes times Q, which is probability of failure, to the M minus N. So we can see some of that as we work out questions. Let's try to do, what time you guys get out of here? 36? 36. Okay, so I'm going to try to do at least one question from our little worksheet over here, and then one question at least from your homework. Okay? All right, so let's take a look at number 1. It says 4x plus 3 to the 4th. Okay? So we're going to come over to a blank page. That's not what I want. Okay, what did it say? 4x plus 3 to the 4th. Okay, 4x plus 3 to the 4th. Okay, so we want to understand first our Pascal's triangle, we have to take it down to 4, right? So 0 is 1, 1 is 1, 1, 2 is 1, 2, 1. And another way that's easy to understand this is once we get to 2, right, it has 2 in it, so that's my to the second. Does that make sense? Right, so 3 is 1, 3, 3, 1. 4 is 1, 4, 6, 4, 1. So I know my coefficients are going to be 1, 4, 6, 4, 1, right? Yeah, okay. All right. So what we're going to do is we know that our first coefficient is 1, okay? And then our first, what is in A position is 4x, right? Yeah. So that's 4x to the what? To the 4th, okay? Times 3 to the, no, 0. Okay, it's our B position. Does this make sense now? Okay, all right, plus. All right, well, 1 was our first coefficient. What's our second coefficient? No. Look, that's the whole reason we did Pascal's triangle. 4. Okay, now I have my A again, which is 4x. Okay, this time the exponent is to the 3rd. Okay, now we need our B position, which is 3. Okay, what's its exponent? 1. Okay, and notice that these will always total to be the exponent that you're working with. So 4 plus 0 is 4, 3 plus 1 is 4. Okay, what's my next coefficient? 6. Okay, all right, what's my A? 4x. What's the exponent of 4x in this case? Second. Okay, what's my B? 3. What's its exponent this time? To the second. Okay. All right, what's my next coefficient? 4. Okay, what's my A? 4x. Okay, what's its exponent? To the first. What's my B? What's its exponent? 3. All right, plus last coefficient? 1. I got 4x to the 0. Okay, I really need to start better. Okay, so now we're actually going to do the math. Okay, now this one, is it going to change anything? Is the 3 to the 0 going to change anything? No, so the first thing I'm going to do is I'm going to take 4 to the 4th. What is 4 to the 4th? No, 4 to the 4th. No, 4 to the 4th, not 4 times 4. We're in Algebra 2. We do understand that an exponent is not the same as multiplying. 256. All right, now x to the 4th. Okay, right? We get this? Okay, plus. Okay, we're ready for the next set. Now all my numbers do apply, and we're going to follow order of operations here. So I have, from left to right, I have 4 cubed, right? So what is 4 cubed? So 4 times 64x cubed times 3, right? So I need to take 4 times 64 times 3 because it's all multiplication, so I can multiply all of it and find out what number that gets. 4 times 64 times 3, 768. So that's 768x cubed, right? Okay. Now, we also notice that in this case, at the very least, right, we're going to start at 4 and work our way on down until I get a constant, which means my variable will be to the 0 power, right, and I'll just have a number at the end. So let's come down here. Now I have 6 times 4 squared, x squared, 3 squared. All right, so I have 6 times 16, x squared times 9. So 6 times 16 times 9. 864x squared. Is this easier than what we would have been afraid of it was going to be? Right? It looks really long, but is there any, like, if we take it one step at a time, is it manageable? Yeah, okay. All right, now we're over here. So really I have 4 times 4 to the first times 3 cubed. So I have 4 times what? 4x times 27. Okay, so 4 times 4 times 27. plus 432x. All right, now I have a 1 and I have a 4x to the 0. Is any of that going to change anything? So just 3 to the 4th. So this should be my answer. Okay? And that's probably B. I don't know. I don't have that pulled up. But like I said, is this manageable? Yeah, okay. All right. Let's see. With that, let's take a look at your homework and see if there's anything in there that you want to work out together. All right, if we have time, we may work out more than one. I would probably start with somewhere in like A through G, somewhere. Now, if you feel comfortable with Pascal's triangle in doing that, you might want to look at a question like E or F or G, either any of those, or it's one of those later things that we looked at briefly in terms of flipping a coin or something to that effect. But I need you guys to kind of pick a question. Or if you want to do another Pascal's triangle expansion, we can do that. Otherwise, there's... That's fine. Pick one, though. Let's see. Okay, so you want to do 1 minus 7x to the third? B. So you want to do f plus 2 to the fifth? I don't care. Now, with f plus 2 to the fifth, f plus 2 to the fifth is not a bad one just because we haven't gone down to the fifth yet. Okay? So, f plus 2 to the fifth. So the first thing that I'm going to do is I'm going to write out Pascal's triangle to the fifth. Okay? So what do I start with over here? 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. And if you put this at the top of your homework paper, you only have to do it one time, right? Because you can use it for all of these questions, right? And then what? Okay, now this one. Okay, all right, so we have Pascal's triangle there. We're going to use just this row of coefficients, okay? All right, so we know that our first coefficient is what? 1. And then my what is my A position here? F. So I'm going to take F to the what? Fifth, and then 2 to the here. In fact, I'm going to squeeze over here because I know it's going to be really long, right? So we got 1, F to the fifth, 2 to the what? 0 plus what? 5. F to the fourth, to the first, plus 10, F to the third, to the second, plus, okay, F to the second, to the third, okay, plus 5, okay, to the fourth, plus, still ran out of space. No matter what I do, I'm always like way too big and spread out on the left-hand side and have to squeeze it over. Okay, so in my first term, I'm going to let you guys think this out. What am I left with there? F to the fifth. Okay, good. All right. What about on this set? I'll let you do the math. 10 F to the fifth. Okay, good. 10 F to the, what did you say? F to the what? F to the what? F to the fourth. Okay, and it should go down, right? All right, plus what? 40 F to the third. Good. No, Look, it's 2 cubed times, right? I got to do all of the multiplication. So 8, because 2 to the third is 8. 8 times 10 is 80. 80f to the second, right? This is going to get, you know, maybe bigger. 2 to the fourth is what? Probably 16. 16 times 5. Is it 80 again? Okay, 80. 80 what? 80f. And then what? What's 2 to the fifth? 32. And f is to the 0 times 1. No changes there. Take a look in your book. F to the fifth plus 10f to the fourth plus 40f cubed plus 80f squared plus 80f plus 32. That's our answer. Okay? Do we feel pretty comfortable about this now? All right, great. Which I think is a lot easier than some of the stuff that they're trying to show. Okay? It's just finding the pattern and then going back and doing all of the multiplication. All right, what else do you want to do? D? D. Oh, you want to do D? Oh, okay. So this actually isn't as bad as what you think. Okay? Now, it just wants the fourth term. It doesn't want the whole thing, right? So, but let's go ahead and find, we still have to find the coefficient though, right? So we still do have to write, you know, Pascal's triangle. Okay, 1, 6, 15, 20, 15, 6, 1, 1, 7, what is this, what, 21? 21, 35, 35, 21, 7, 1, 1, 8, 28. All right, what's next? What, 21 and 35? 56, 70, 56, 28, 8 and 1, right? Just gonna have to spread out. 1, 9, what, 36? Okay, help me out. 84, 126, and then we're what? Oh, yeah, 126 again, and then 84. We're going back down. 36, 9, 1. Sorry. We ran out of time. But you only need the fourth term. So once you get, you know, you got really 110. What's this next one? It's going to be, what, 45? All right, so that's the third term. The fourth term, what's 36 and 84? What is it? 120? Okay, so we already know that our coefficient's going to be 120, right? It's the fourth term of, what was this, x plus 3? So x plus 3, that x has already gone through, so it started out as 10, has gone down to 9, 8, 7, so it's at 7, and that 3 has gone from 0, 1, 0, 1, 2, 3. Yep, so it's at 3. So all I have to do is simplify this. So I'm going to take 3 to the third times 120 and have x to the 7th in that. So whatever that number is. So let's take 120 times 3 to the third, 3240. X to the 7th, and that's all I've got to do. Yep, it's just that easy.